we have a question here that says, you measure the length of a spaceship at rest relative to you to be 500 meters. How long will an observer measure it to be if the observer flies past a spaceship at 0.75 c, which is 0.75 times the speed of light? You can see here we're dealing with relative velocities, and because these velocities are very close to the speed of light, we're going to deal with length contraction. So two observers measuring an object are not going to be measured. They're not going to measure the same length of it. It's going to be contracted for one. First thing we do is we draw a diagram to look at the situation and try to understand it a little bit more. It's good because it helps you get in your head what's really going on. So we have you measure the length of the spaceship at rest relative to you to be 500 meters. So let's say this is your frame of reference. We'll say S, and there's a spaceship. No, there really shouldn't be any propulsion because it's supposed to be at rest. Let's say that's a spaceship. You measure this length here, and you measure the length to be, say, 500 meters. If we have a second observer in a different reference frame, say reference frame S prime, which is flying at a velocity of 0.75 c, what are they going to be measured this length of this spaceship as? So that's basically it. We have ourselves as stationary with regards to the rocket, and we have this someone in reference frame S prime, some observer, if probably in their own spaceship, and observing this spaceship, which they would see in their reference frame as traveling to the left at some velocity, if they were to consider themselves stationary. But since we can see this is a length contraction problem, we can simply get our length contraction formula, which we derived in a previous video, which says that L prime is equal to this value here, 1 minus V over C squared, times our L value, where L here is our proper length. Now, we have two L values, L prime and L, where L is our proper length. Which one is measuring the proper length? Which reference frame is measuring our L value? Well, we defined our proper length as it's the reference frame that measures the thing that's being measured, and they see it as stationary. So the thing that's being measured is stationary in their reference frame. They measure the proper value. There's only going to be one reference frame in which the object being measured is stationary, and the rest are going to seem like they're moving. Now, in the question, it tells you that you measure the length of a spaceship at rest relative to you. So that's saying you're measuring it at rest, you're measuring it, it seems stationary from your point of view. While from S prime's point of view, they would see that the rocket as as traveling at some velocity to the left. If we were to draw this sort of same situation here, that's your reference frame. This is S prime. And I'll draw the same rocket here. They would see themselves as stationary, and they would see reference frame S moving at negative velocity, and this rocket also moving at negative velocity, where the velocity was 0.75 c, and they would consider themselves stationary. So in their reference frame, the thing that's being measured is moving. They're measuring this rocket, but this rocket is moving relative to them. But S sees this rocket as stationary, or at rest relative to that reference frame. So therefore, they measure the L, or the proper length. And that's going to be equal to 500 meters, since the question tells us that they measure it at rest relative to them to be 500 meters. So the proper length, therefore, is 500 meters. So our L prime must be the length measured in the other reference frame, in our S prime's reference frame. And that's what we're looking to work out. We're looking to work how long will an observer measure it to be. How long will the person in the spaceship measure it to be, which is L prime. So now we could just simply solve the formula. We'd have this value here. We know the value of V. V is 0.75 c. So we get 1 minus 0.75 c divided by c, and that's squared. And we're timesing that by our 500 meters. Now we got 0.75 c divided by c. Well, these c's are just going to cancel. We're going to be left with this, our 1 minus 0.75 squared times our 500. Now what is 0.75 squared? Let's say we've got 0.75 squared, 0.5625. So we get 1 minus 0.5625 times 500 meters. Now we go 1 minus this value would give 0.4375. So 0.4375 times 500. We take the square root of this value here. So we simply say square root, and we get this weird number. And so we're going to get this number here as 0.6614, and we're going to be multiplying that by our proper length, which is 500. So we'll skip a step and we'll simply just do that. So we're saying times 500. And that gives us 330.72. 330.72, and that's going to be in meters. So L prime, or the length that is measured in that spaceship traveling at 0.75 c, is 333.72 meters. So they're going to measure this length of this object to be less than what is measured in the reference frame of S, and that's simply just consequences of length contraction. So that's all you'd have to do for a problem that's just like this. Simply work out which one is a proper length, which one is L and L prime, and simply plug in your values and then just solve for whatever you need. And that's basically it.